Good afternoon. Welcome to the Butler Manufacturing Services webinar on surface water management. Thanks for coming along. They're waiting for a few to join. But in the meantime, um, what the webinar is about is we're going to talk about surface water management as regards to how to safely manage rainwater that falls on impermeable surfaces and then release it at a sustainable rate and with the focus on geocellular systems to do this management. So at this stage, just if you've any questions you'd like to ask, or if there's if you have any expectations or anything special you'd like us to cover in the presentation, please let me know. But please stop me at any stage and ask questions because that's where we find the most benefit or generally out of these presentations. This presentation we've done quite a few times to numerous different engineers and consultancies, and we've refined it over time. So it's mostly an educational piece to show you how to select a geocellular system and different types of systems, and then also it also showcases the abilities of BMS and what we can help you with. We've been supplying surface water management systems for more than 40 years. So we have quite a bit of knowledge and quite a bit of experience. We haven't seen everything, but we've seen a lot. So we are a full service manufacturer in that we can design your system from the bottom up. We can manufacture it and install it and certify it. So I'll just give it a few more minutes and then I will start the presentation. And as I said, please feel free to ask any questions at any times. Okay, I'm going to kick off the presentation and you can ask questions either via the chat function, or you can also just unmute yourself and ask me a question. If you please make sure to mute yourself when you're not talking, just so we don't get any interference for any other people in the presentation. So to start off, an overview of what we're going to talk about. I'm going to talk a bit about the company that I am a director of. I'm third generation it's a third generation family company, and tell you what we do. Then we're going to go into sustainable urban drainage systems, which is SUDS is short for design. Then we're going to define what is the difference between attenuation and infiltration and give some examples. What most people are interested in from a developer to an engineer is how to select a correct system for differing sites and what to look out for in the product to make sure that it's suitable and that it's going to last a long time. Then after that, what a lot of the planning authorities are interested in, and therefore most people put them in are interested in, is post-installation maintenance and how to do that maintenance. And also to do that maintenance. And finally, we're going to go through some case studies showing you some real life installations, how they were designed, and also talk about complementary products in the area. There's a lot more than just attenuation infiltration systems in surface water management. There's petroloid interceptors. We'll go quickly through them and how to select them. Vortex silt and oil separators, which are becoming more and more important. Vortex outlet flow controls, which control the flow out of it, and other products. So, as I alluded to, we're a long time in business. We're one of the longest established, even worldwide, in wastewater treatment and surface water management, especially the niches we function on. We have products. We have product in 50 different countries, and that's over the space of 40 years. We focus on being a quality manufacturer, which provide great value. We're definitely not the cheapest, but we provide backup, service, design, and quality products that are built to last. Many of our sewage treatment systems and interceptors are more than 30 years old and they're still functioning fine. We have files for every product we manufacture, and that's part of our ISO 9001 quality. We do constant research and development, so we're always developing new products and always responding to what our customers tell us. So one example you'll see this later on is called the Stormbreaker Defender, which is a vortex silt and oil and debris separator, which is a market leader and is very unique in that it comes in completely one piece, makes it very easy to install and can be transported by container. So we have two main sections in the company, wastewater treatment and then surface water treatment. I did last webinar on temporary packaged sewage treatment solutions in the form of our BMS Blivet, which is it's the leading packaged sewage treatment system available for temporary, permanent, or emergency installation. And you can find that webinar on our site, or please inquire if you want to discuss more. Surface water one-stop shop from design to installation. So we can go from initial site layout, do full calculations and everything, produce a full surface water design for planning, and then we can manufacture the product and install it and certify it from top to bottom. An increasingly popular product is, from a planning point of view, is a package wash water recycling system, which recycles the water from car washes, truck washes, bus washes, even container washes for continuous reuse. We can see increasingly in Ireland and abroad that planning authorities are clamping down on discharges from car truck washes because they're quite dirty. So more and more people want a solution that will clean the water, allow them to save in water, but the recycling also is plug and play, goes fully above ground, and there's no dirty water discharge. And of course, we do package pump stations, and we have special ones that can go in containers for export abroad. So, sustainable urban drainage systems. What is it? What does it mean? It's a total solution to stormwater management. The traditional solution 20 years ago would be if you were building a new site and you're covering a previous green area with an impermeable surface, is just put in piping and divert the rainwater somewhere else into a river, sewer, water course. And what this did is the more that was built, the more you get flash flooding events where the surface water discharges. So the idea now is that you manage all the surface water generated on site, you store it, and you release it at a sustainable rate. So that's what a sustainable urban drainage system is. The U is kind of smaller because it's really sustainable drainage system. It's it's a regulatory requirement in practically every country in the world now that you manage your surface water flows, because obviously you can see with climate change there's more and more flash floods. There's more damage coming from storms. So the more that surface water, the bigger the ability to manage surface water on site, the less problems are going to be caused to the surrounding environment. So basically what you're trying to do is if you had a field, a green field, the rain will soak into it to a good extent before it floods. If you cover that with impermeable surface, there would be no soakage and the rainwater is displaced. So what you're trying to do is make up the deficit, or even better, the green field flow post-development, so that the post-development the site will still be able to store as much stormwater, not divert it away and release it at a sustainable rate. And how do you do this? Well, in attenuation or infiltration system, which is an artificial void you build under the surface to store and manage the water. Ponds, if you have no space, permeable paving can be part of the solution. Blue or green roofs and rainwater harvesting can also form part of the solution. So, but we're going to focus on geocellular solutions. To sum up, what you have to do on all new sites and brownfield sites is to make sure that you have an appropriate solution to store the surface water that falls on the site in the form of rainwater, and then to release it at a sustainable rate so it doesn't cause flooding downstream or in the area or damage infrastructure. So, as we said, how do you size a SUD system? Well, you estimate the greenfield runoff, which it will be the runoff from from a permeable surface like a field, pre and post development. You see what the deficit is after development, and then you have to make up that deficit by storing it on site via the solutions we already talked about. But we're going to talk about mainly about geocellular solutions. So how do you do this? Well, one good thing is full service manufacturer like ourselves can do it for you. We have a special software called MasterTrain. There are other softwares available. Your local authority or planning authority might stipulate a certain runoff rate from the site and a storage rate. And there's various methodologies to do this. One's called the Wallingford method, and if you register for that UK SUD site, you can actually do the calculations on that. And the gold standard for guidance in the area and for how to structural design of systems and everything like that, and incorporates another one called Syria 737 is the SUDS manual, Syria C753, which is planning, design, construction, and maintenance of sustainable drainage systems. And what kind of storage volume we're looking at? Well, it's generally, when we started off, it was a 1 in 10 year storm. Now it's generally the gold standard is 1 in 100 year storm, which seems to be happening every 3 or 4 times a year, and it's even gone up to 1 in 200 and 500 sometimes now. So it's very important to get that right to stop flooding on the site and downstream, as I said. So that's an example of a SUDS calculation from our system. It's quite elaborate and it's site specific. So it's using kind of rainfall data and everything like that, and the drainage in the area to work out how much storage you need and everything like that, and then for appropriate for a 100 year storm and the surface area and everything like that. So that's a service we provide complimentary to our customers. So moving on to geocell solutions and attenuation versus infiltration. What are they and what is the difference? Well, it's a fairly simple difference between the two of them. Attenuation is where you build an artificial void under the impermeable area, and you then seal it with an impermeable geomembrane such as 0.5 millimeter HDPE or a clay liner. So what happens is the tank fills up during rainfall, and then you put an outlet flow control on it, which controls the rate out of it. So, for example, a common rate you'd see maybe might be 4 liters per second, 10 liters per second, and those outlet flow controls, we do the BMS storm break are all custom designed to achieve a certain flow out of it. And so if you get a heavy storm, the tank would fill up, and then the idea being it releases at a sustainable rate. So the tank itself doesn't allow infiltration into the ground. And you can see, for example, the BMS storm breaker, which is built there, when it's wrapped with, which is then wrapped in a geomembrane. You can see that is completely impermeable. It fills up and then allows it to infiltrate, allows it to flow out at a sustainable rate. And this is versus infiltration. And infiltration is where you still build an artificial void, but it's actually not surrounded by an impermeable membrane, but this time it's surrounded by a permeable geotextile, such as a non-woven geotextile, 300 grams, and the tank fills up during rainfall. But then when the groundwater table surrounding it starts to go down, the actual surface water stored in the infiltration tank will slowly infiltrate back into the ground. So it mimics natural drainage really. Um, what what are the advantages, disadvantages? Well, an infiltration system is generally easier to put in because you don't have to put a sealed membrane around it. But it is really only suitable when you have a groundwater table that will allow infiltration, and also it's not as suitable close to a building. But generally, infiltration system would be favoured due to the ease of putting in. But sometimes you can actually get a combination of the two, where you have an infiltration system, but you also include an outlet storm control. An outlet vortex flow control. So when it fills up, you will get some going out via the sewage, and then you will get some infiltration into the ground. So the main thing to sum it up, attenuation system is an impermeable system, and an infiltration system is a permeable system. And that often you see a lot of infiltration systems or tunnel-based systems. You can see a picture of the BMS Drain Max there, which is a permeable system. And they're all put in like that, and then they're wrapped in a geotextile. So the main thing from an engineer's point of view, or generally from a developer's point of view, is if you're looking at a system or you're looking to assess a system, what do you look for? Well, first of all, you need to make sure that it's providing the capacity that's required. So that can be anything from 10,000 to 500,000 liters to more, depending on the site. That, as I said, is calculated by the impermeable surface and the local weather conditions, um, and the actual amount of rainfall wants to be contained. The other thing then is, what dimensions do you have to work on in site? Do you have a green area? Is it a very tight area? Is it a deep, shallow, narrow area? So that often will dictate the levels where it can go in and how much of it you can put in, and also the void ratio of the product. So if it's giving, for example, like the BMS Stormbreaker, 97% void, it will 97% of the space provided by the Stormbreaker will store water. And then how much stone you're going to put in. And generally, we'd work with stone porosity of about 47%, which is you have to get stone that's certified to that, but that will give a void ratio of 47%. Will add to the attenuation or infiltration volume. Again, is the system going to be in a trafficked area, heavily trafficked area, or a green area, which will dictate a lot on the system. So you have to be very careful that a system that's put in, especially in an area with high vertical loading, for example, the maximum in Ireland is a 10-ton axial loading, although the systems we do can take a lot more than that. That the system is put in at an adequate depth and has adequate cover to be able to deal with this constant loading. Um, and as regards certification, there is no European or EN standard that covers attenuation or infiltration systems. But then the designated route for one of these systems, certification with the EU, is Agremont certification. Um, so the BMS Stormbreaker, for example, is fully Agremont certified. There's a detailed certificate which took a very long time to actually get through past the NSCI with detailed testing on strength, loading, depths of installation, how to install it, performance, and everything like that. That can be downloaded from our own website, or we can send it after, or the NSCI website. In Germany, they have a slightly different route. It's called DIPT certification, which is the equivalent of Agremont certification in Germany. And the BMS Max tons have this. And again, it has detailed calculations, loadings, and everything like that. And that's available from our website. It's really important to have one of these certificates, because it's the only way to get independent verification of the strength, loading, and attenuation capacities or infiltration capacities of a system. Quality, it goes without saying that any system that has been put in should be manufactured under an ISO 9001 quality system. And then design life. What design life should a system have? Well, generally we'd see most people are looking for 50 years plus in a system. So does the Agremont certification or the DIPT certification show this? Again, what I was saying again, this is really important to think of both during construction and after construction. The depth of cover, this varies a lot from system to system and can be seen in any proper certification like DABT or Agremont. If it's especially if it's being heavily axle loaded, as we said, that as we allude to the 10-ton axle loading, it's very important that the depth of cover is adequate to be able to sustain this. And one other thing is just to make sure, as an engineer on site, is that if a system is put in, that the adequate cover is put over the system before machinery is ran over the system to make sure it doesn't damage it. That's just pertinent site control, but it's fairly easy to do if needs be. Um, so, as I said, these in depth of installation, different systems allow different depths of installations as well, and this varies a good bit depending on ground conditions. What design advice or technical backup does a company offer, and also what is who is the designer and supplier? Do they offer full design, or full design solutions. So to sum it up, there's a variety of considerations you need to think of when doing an attenuation system, from capacity to dimensions, to loading to certification, and depth of cover. But we can provide a full solution on this. So if you just give me just one moment. Sorry, apologies on that. There was someone streaming outside my house just as I was doing the presentation. Had to ask them to stop. So I used to do live presentations. Now, moving on. Now, um, post-installation maintenance is a really, really important factor. And when you're talking to a planning authority, they generally will want to know, how do you maintain a system properly after? Or how can you maintain a system? So there are ways to install attenuation infiltration systems so that they're essentially maintenance free. So with the crate type system, like the BMS Stormbreaker, what you do is you run a perforated pipe through a stone bed underneath the Stormbreaker. You can see it there. It's actually a part of the system. It's part of the it's sealed in the impermeable membrane, and then what it does is it's a perforated pipe, and it allows the actual surface water to infiltrate into the stone, and with all the solids being kept in the pipe, and the self-cleaning velocity of the pipe will wash the solids through the pipe out to the other end. And if it's combined with a petrol oil interceptor up front, which will take out petrol oil and silt, and then afterwards with something like a vortex silt and oil separator or BMS Stormbreaker Defender, it is practically maintenance free, and all the maintenance is in the inlet and outlet manhole. And with a tunnel type system, what you actually do is you install this. We pioneered this. It's called an isolator row. So what you do is Dramax tunnels have perforations the whole way down, which allows the water to infiltrate out into the bed around. So that we generally channel um, all the flow into one row, which is surrounded by a permeable geotextile and has a MacTech liner in the bottom. So this means that all solids and everything will be maintained in just one row. So maintenance can be done in one row, which can also be jet washed. And also, yeah, again, if it's combined with a petrol oil interceptor or vortex separator, you can it will make maintenance very, very simple and straightforward. And this is the type of option which is favored by most planning authorities, because they're worried about systems silting up and how they're going to be maintained in the future. So regular inspection of the inlet and outlet manholes with the perforated pipe, with the Stormbreaker, or the isolator row with the Dramax will make sure the system doesn't get silted. As I said, it can be jet washed out as well. And the Stormbreaker Defender, which we'll talk about later, only and the petrol interceptor will aid this. And of course, you can put silt probes into and oil probes into a petrol line interceptor, and you can actually use solar alarms for those two now. So in summation, maintenance is something that planning authorities will generally be very interested in. So to get around this, with tunnel type systems, you install um, an isolator row where all the solids are maintained in. In a crate type system, you install a perforated pipe to a stone bed, which is part of the system, and a perforated pipe, and all the solids are maintained in that. And in combination with the petrol interceptor and a Stormbreaker Defender, Vortex oil and silt separator, It will make maintenance very straightforward in line with just a regular maintenance inspection regimen. So, sorry, I was just a bit out of breath there for a second after trying to stop the noise outside. So, as I talked about, there's a lot of different sorry, at this point, does anyone have any questions? I've covered a lot there. I'd welcome any questions. You can do it by chat, or you can just ask me directly. No? Well, also we can be emailed after, or I can be contacted just phoned at work after if anyone wants to ask any questions, myself or my colleague John Lee. So within surface water management, I've alluded to a lot of different other products which form part of the suite of products or the way to manage surface water. Where we would have started off originally was producing petrol oil interceptors, which are also called separators. Sorry, just one sec. I think I have a question here. One second. Oh, no question so far, which even was the question there, so even better. Um, so petrol oil interceptors, what we started off with, their role is to stop petrol and oil coming off an impermeable surface, getting into surface water or into drains or rivers. So they remove petrol, silt, and oil, and there's two main types called one called full retention, the other called bypass. I'll go through how to select them in the different terminology in a minute because we're often asked about the same. And we're doing them about 35 years now, and they're under practically every main road in Ireland, a lot in the UK too. I've exported them as far as Tanzania. Silt traps, they're a simple measure normally on sites or car washes to remove silt and debris. Um, Vortex silt and oil separator. It's Stormbreaker Defender is our brand of it. They're used upstream and downstream of stormwater flows to remove silt, oil, and floating debris. So they could be used in their own where there's a surface water discharge into a river to remove that, or often used in conjunction with surface water management systems. Um, in some sites, you can use bigger GRP holding or attenuation tanks. We also do chemical resistant tanks. We've done them for the likes of Dublin Port, and we can custom manufacture those. Rainwater harvesting tanks certainly help as part of the volume. They won't provide a full solution, but they certainly help as part of a suite of products. And sometimes there, depending on levels of site, package pump stations are required to pump the water away to a different level. So moving on. Now, interceptor sizing selection. Just to point out, petrol oil interceptors are often called separators. It's all the same thing. There's a European standard which is used, which all manufacturers should follow to size and select them, and that's called EN 858 parts 1 and 2. So there's two main types. There's a full retention interceptor and a bypass interceptor, and you'll often see it shortened down the full retention to an NSF, which means nominal size full retention, or an SBP, which is nominal size bypass. And that's just, and then with the figure after it, and that the figure after refers to the actual level of flow it can take. So full retention interceptors, they're installed on areas where there's a regular risk of a large spill, normally where there's fueling on site, like petrol stations, where there's vehicle maintenance taking place, or there's lots of vehicles, lots of heavy goods vehicles, and they have to be able to contain the full contents of the spill and flows up to 50 millimeters per hour. So, and they're quite a lot bigger than bypass interceptors. Apologies on that. Um, and bypass interceptors are smaller, and the reason for this is that they're able to treat a flow of up to 5 millimeters per hour, and after that they bypass. That's why they're called bypass interceptors. Um, this is where there's low risk or small risk potential of oil spills, such as car parks and roads and things like that. And the idea being that if you have a dry period, that 99% of the pollution will come in the first flush, and the interceptor takes it out, and then after that is just surface water, which is fairly clean, be discharged. And then you'll often hear a class one or class two interceptor. And that's simply that a class one discharges surface water and has to have less than 5 milligrams per litre of petrol and oil. And a class two will be suitable for discharge to a foul sewer and has less than 100 milligrams per litre of petrol oil because it's going to a sewer. And I said the design is 2EN858. How to size and select them, it's pretty easy with interceptors. You work out one, you're at the surface the full surface area meter squared of impermeable surface draining into the interceptor. Whether you need a full retention for where there's a large risk of a spill or a bypass interceptor, and then you just select an interceptor of appropriate size. There's full selection charts available on our website, or we can do it for you, and our brochure can be downloaded from our website. So, is there any questions on interceptors before I move on? Thanks. This is a next product. It's a relatively new product on the market. It's it's they're becoming more and more popular. And after customer feedback and a lot of work, we work with the University of Galway to produce an innovative Irish designed and manufactured vortex oil silt and debris separator. And what it basically does is it uses vortex dynamics to actually spin out silt, oil, and debris, and then it releases them. So they're non-powered, but they can provide a very large degree of silt oil separation and even heavy metals. We're looking at doing further testing and performance of ours at the moment, but they are unique in that they come ready to go. So all they have to put in the ground, no extra manholes and things like that, and just with the concrete around, and they're ready to go. They can be used upstream and downstream of surface water flows. Often you hear colloquially, used downstream, but they can be used for both. And how do you size them? Well, there's three different sizes basically. There is a size A, which can do up to 30 liters per second, B up to 85 liters per second, and C up to 250 liters per second. And they're all custom selected based on the average flow and peak flow, the inlet and outlet pipe size, and the height at the discharge point. And what we're looking at all the time is we're trying to minimize head loss and maximize the grit, oil, and debris removal. But all our units uniquely fit in a standard container on a truck as well, which makes them very easy to move. And if you ever get flows over 250 liters per second, which is quite big, it's easy to put two in and just separate the flow between, because it makes moving on site a lot easier. And that was a big feedback from our clients and engineers about having stuff that are actually easy to put in. And that's one thing we've always focused on, producing products that are delivered ready to go. And finally, outlet flow controls. I alluded to these, mainly put in attenuation systems. So the attenuation system fills up, and then the outlet flow control is manufactured to produce a certain maximum output. So it can be anything from 1 or 2 liters a second up to maybe 200 liters a second, depending on the site and requirements. The idea being that it releases a sustainable rate to stop surface water flooding downstream. So you can see some pictures there of a variety of different designs, and they were actually all put in on the clean bypass. So you see a variety of different sizes. They're all in stainless steel, and they're custom manufactured to suit a round or square manhole, the head of water coming in, and the required outlet flow rate. Um, they have maintenance wise, we often get asked that there's a handle built into them which is customized to the manhole height, which allows them the actual unit to be taken out from manhole height to check them, just to prevent it, check if there's any clogging or blocking, and they're manufactured in stainless steel. So to sum up, um, as regards BMS and what we do, we've always regarded ourselves as a full service manufacturer. So what we can do is take your initial surface water designs, do the full calculations, and produce a design which will meet all your surface water requirements and allow you to manage the surface water on site and release it at a sustainable rate. This includes specific calculations and drawings, which for planning authorities, and we also assist with site layout and we can go as far as to install the product, supervise it, and certify it. And we also can recommend, or we can provide on occasion ourselves, a geotextile or geomembrane installation service. So the putting in a system can be logistically complex on site because it involves ground workers, it involves putting the tunnels in, and requires geomembranes, geotextiles. So it's always to bear that in mind, in that working with the manufacturer that can actually provide all this can save a lot of problems and save a lot of time. So, any questions before I move on to some case studies? No? Well, basically what we're going to look at here is four different installations. Two are tunnel type systems, mixture of attenuation, infiltration, and then we have one crate type system, and then we had a unique pre-assembled system which we did at our factory to meet site requirements. And again, before I start, people would often ask, when do you put in the tunnel systems and when do you put in the crate type systems? Well, tunnel type systems are ideal, especially when there's not very high loading and we can achieve enough cover, and also because you can include a lot of stone with it and there's a lot of space available. They will be generally our recommended solution if you have enough space and you can provide adequate cover. Now they are very strong and provide for 1 ton axle, 10 ton axle loading, but they need a meter cover over them, where the crates need less cover, maybe about up to about 600 millimeters over them, and they can go in a lot tighter spaces and achieve more attenuation volume in tighter space, although they are more challenging to put in. So that is the school in Longford, and this installation's been in for about 10 years. So that's the finished school. So that's a picture of the tunnels going in. So there's generally 450 mil between them. They're put in, they're overlapped together. You can see the holes in the side of the tunnels, and that's what allows the surface water to infiltrate into the stone and everything bed around. And that's also part of the isolator row solution. So you can see in the drawing there, the there is one, two, three, four, five. There's seven rows, and the total volume is 235,000 liters. And the middle row is the isolator row. So all the flow is directed into that. It's surrounded with the permeable geotextile, which allows all the water to infiltrate out into the rest of the infiltration volume, but all the solids are maintained within that tunnel, and these are washed out to the outlet manhole, or they're taken out by a petrol line interceptor or stormbreaker defender. But all the maintenance there, and they can be jet washed. So this is quite important. So next up is it's a 275,000 liter installation for lithium meat. So it's in an industrial location. So you can actually see the geotextile on the ground there. And this is actually using tunnels, and tunnels can be used for attenuation as well, because in this case, it was actually impermeable membrane was put around them. So it's actually an attenuation system rather than infiltration like the previous one. So you can see the actual geomembrane underneath, which is kind of the black rubbery surface, and then you put geotextile on top of it to prevent any piercing of the geomembrane. And you can see the tunnels just overlap. They're quite easy to put in. And then that is the finished system with the before it's backfilled with the fully sealed membrane around it. So that is a typical calculation that we do for all our customers. So it tells you, the required volume, and then it uses stone porosity and different levels to produce how many of the Max tunnels you need to basically to meet your storage volume. So you have stone requirement of 393 meters cubed. Yeah, you can see the length of the system and everything like that. And so we meet our storage volume at the end. And we can tailor those depending on levels and size and everything like that. So again, you see the system uses the isolator row technology, which is marked in blue, and it goes and all the surface water flows direct in there, and the maintenance in the inlet and outlet manhole. And then moving on, this was residential development we did for Cairn Homes, off the top of my head, in Ashford in County Wicklow. And this involved three different tanks of three different volumes. It was so you can see a Stormbreaker or crate type system being built up there. So the systems actually interlock into each other, which gives a lot of strength, but and they are very safe to walk on, and it means they're very, very strong when they're put in. The only downside being that when it's put in, that the actual under the stone bed underneath has to be very level to make sure the crates are very easy to put in. They are a very good system, and it's Agrimont approved, and which was we hold a European design trademark for it, and they're manufactured in Ireland. We can see all the stage of it there. So from the system being put in to being surrounded by the geotextile, so that was infiltration to being covered. So that's the full drawing of it. In this case, there was two perforated pipes you can see running through right through the middle of the system, and they're surrounded by a geotextile. So the self-cleanse and velocity of the water going through will wash all the solids out. So this makes the system virtually maintenance free. And I said if you combine that with the petrol line interceptor up front, which you can see was done, and an oil silt alarm, this will prevent a lot of maintenance problems. Which again, sorry to hammer on, but it's what generally planning authorities are most interested in is is the required volume there, and kind of will it silt up or not. So another big advantage of the crate type systems as opposed to tunnels is they can go in a lot of different more variable depths and different geometries. You can see the perforated pipe is running through the middle kind of diagonally there in that one, but that was to suit that the site conditions. It's 8 tiers deep with only in a green area with 438 mil of cover. So obviously in any kind of green area you need less cover than you do in a heavily trafficked area. And tank three, this is a trafficked area, so it's more covered as you can see. It's 40 tiers deep, and again, it has the perforated pipe running through it, and it's 600 mil of cover. And this is an interesting one. This was on Aylesbury Road, and they were renovating the house, and they had very big access problems. So if they didn't have time to open excavation and build a system in the ground because it would have closed off the site. So this can be done for any site, but it's quite a good solution to see, good way, apologies, to see how Stormbreaker system is built up and goes in. So this is at our factory. You can see the geomembrane underneath and the Stormbreaker being laid out on top. There's geotextile underneath that. The system being built up, you can see it clicks into place and into the required shape. Now, in this, obviously, we're restricted by the dimensions of a truck, so that defined the width and the length. You can see that is a full 20,000 litre volume built up there, and the geomembrane is ready to be wrapped around it. Then it's pulled up around it, and it is sealed with a special welder by specially trained people, and then it is surrounded by a geotextile, not a permeable geotextile, to prevent any puncturing of the geomembrane. And you can see that's it, ready to go, put on the back of a truck, and then it went to site, and that's the hole dug, and it was lowered into place and covered over in 2 hours. So that's the quickest attenuation system I think we've ever put in, but it just shows that we have a lot of experience, and we can do a lot of innovative design if required, and that could be done on any site. We could do modular installations. So um, that is the end of the overall presentation. As I said, you're welcome to ask any questions. If I don't know the solution, if I don't know the answer now, I'll certainly find it out and get it for you. So to sum it up, SUDS is a total solution stormwater management, where we're managing surface water flows on site and preventing the surface water flows being diverted downstream, where it cause flooding, infrastructure damage, and everything like that. And what deficit are we trying to make up? Normally, something like a 100-year storm is standard at the moment. How do you achieve this? Well, it can be done with ponds, permeable paving, rainwater harvesting. But the most popular way we find, and generally, unless there's a lot of space, is geocellular attenuation infiltration systems. Attenuation system is where a system is an artificial void is built up with crates or tunnels and then surrounded with a non-permeable geomembrane. The system and an outlet flow control is placed at the end. The system fills up and then it's let out at whatever the maximum rate the outlet flow control allows, like the BMS storm break. So, for example, 4 liters per second, or an infiltration system is the same product, tons or crates, but surrounded by a permeable geotextile. So when the water table starts to go down, the water naturally infiltrates in the ground, which mimics natural soakage out. Looking at these systems, how do you select them or how do you assess them? Well, the strength of the system, the level of cover, the design backup allowed, the quality, and certification are really important. Many systems, they can look very good up front. They can be they can look very cheap, but are they including a lot of stone? Are they including insulation? What's their backup and quality? Because these systems go in the ground for 50 years. So it's very important to know all that. And again, just the maintenance of the systems, if you're putting in for planning with the local authority, and obviously some are more sticky than others. We've good knowledge of this. They're very interested in how the systems can be maintained. And as I said, we've innovated two solutions to make maintenance very small in the perforated pipe and through a crate type system, or an isolated row in a tunnel type system. And then other factors are there's a suite of other products that help with this. A petrol line interceptor with the silt and oil alarm will, if that's put in upstream, that'll help largely prevent a lot of silting up of the system. A vortex silt and oil separator can do the same job, can be put downstream or upstream. An outlet flow control is a really important suite of products which limits the flow to a sustainable rate in the outlet. And sometimes you might need rainwater harvesting or pump station solutions, but we have knowledge of all these. So to sum it up, we we are happy to provide a one-stop shop for all surface water management from design to installation, and we use our 40 years of experience to help you with that. Um, and we're here for the long run, so we're not someone that's Johnny come lately. We're here and we're easy to find on the Strokestown Road in Longford, and we've dealt with 50 countries around the world. So I'm just going to finish up with that, and I'd be delighted to ask any questions anyone might have. You can do it by text, or you can do it by unmuting yourself. Um, uh, one question we did receive was as regards CBR plate testing of a site. Yeah, it's part of the certification. If the ground conditions in the site are uncertain, or the ground's uncertain, so plate testing should be carried out, or CBR testing. But there's plenty of qualified people that provide this, or consultant engineers themselves often will provide this. Any other questions? Nope. Okay. Uh, Quiet audience, but thank you very much for attending this presentation. We will be posting it up online, so if you watch our LinkedIn page or other social media, we'll provide a link so you can send to your colleagues, or you can review it again if you want to. And thank you for your time. And we're hopefully going to do regular webinars over the monthly on wastewater and surface water management, and we're posting the next webinar the next week. So thanks again, and just check us out on our website, www.butlerms.com. You can ring us on +353 43 332 6100, or email us on info@butlerms.com. Have a good day, and thanks.